Hey, what's going on, guys? Komakigenzi here. I've been criticized for using global variables all along the way within my bitboard chess engine in tutorial series here on chess programming channel, so I've decided to make this little video introducing a simple technique of how one can mimic object-oriented approach while writing code in plain C. So if you're interested, without further ado, let's actually start writing some code. So the very first thing to consider, I want to say libraries and include stdio.h, which is needed in order to make use of the printf statement and printf function. Also, I want to provide the main driver here. So int main, and as far as this is the integer type, it needs to return 0. So the main function is the place where the compiler is looking for a main function to kickstart with the code execution. Okay, so now let's open the terminal, the current working directory, and by typing gcc op.c -oop, so this would be the name of the binary executable, and if it compiles, I'm going to run the op. Okay, so the next thing to consider would be to create a structure that mimics class behavior. Okay, sorry, like structure like this. So I want to say type def. I'm using type def keyword in order to convert the structure to some sort of a C data type at once. It's just easier to make use of later on. So type def struct, and I call it my class like this. And our structure would be containing so-called, I just call it a class in quotes because it's not a class really, but just to reference the object-oriented programming here. So class inner fields, and also here we have class methods. Okay, so the inner fields would be quite pretty simple. So let's have int a and int b. Okay, and we'll drop the methods for a while, so we'll add them a little bit later. So the very first thing to consider, I want to create a class structure instance. Okay, and I just say my class, and the name would be my class. So this my class should be treated like int or character or whatever, but this data type is called my class here. So my class equals to, well, just grade 1 without anything else. And also let's try to print the variables that are encapsulated within this sort of a structure. So I want to print the a and the decimal specifier, and I reference my class.a. So just like we're doing in object-oriented programming, let's say like in Python, so we can say dot and then reference the variable name, the inner variable. So it's quite pretty similar here. And also I want to do the same for the variable b. They might have absolutely random values at the moment, or zeros. Well, in this case, these are the zeros. Okay, but doesn't matter. So here I want to initialize inner class structure variables. So let's say my class.a would be equal to 10, and my class.b would be equal to, say, 5. So let's print them again, and we have this a and b has been initialized. And obviously, if we want to make some sort of an operations with these values, we can simply create a method that actually allows us to do that. But how to make this method to be called as our structures element using this dot notation. So now I'll just try to introduce this sort of a step. Well, first let's say this would be add class. Let's say, yeah, add class method. Well, again, I'm taking this class into quotes because it's not a real class method. So we would be just using the pointer to this sort of a we would be using the pointer to this sort of a method. So let's create the integer add, and it would be taking int a and int b as its arguments, and it would be simply returning the sum of them. So return a plus b. So quite pretty simple. And obviously, it would just say, int sum would be equal to add, and I now can say my class A as the first argument, and my class B is the second. And if I just print bring the sum at the very end, well, obviously this would be equal to 15 because that's the sum. So sum like this. But what I want to achieve here, I want to call this add method from within the structure to mimic the behavior of the real class instance. So in order to do this, I can define the function pointer within my structure, and this is the core gist of the entire tutorial. So in order to define this sort of a pointer to the function, I need to say integer, because this is the integer type, and then pointer to, and then the name, so this add, okay, and then list the arguments it's taken, so int a and int b, okay. But nothing happens yet because we're just calling this function directly. It's not a big deal. So another thing to consider, apart from initializing the inner class structure variables, we also want to initialize inner class structure methods. So we can simply say my class dot add equals to add, and that's it. So in this case, this add is the name of the function, so this function pointer, and this add is the actual function that we're trying to reference here. And from now on, we can do this quite pretty nice trick. So we can simply say like my class dot add, and now we have absolutely the same result, but we're no longer calling this add function directly, but we're calling this from within our class. And now if we want to have a couple more functions, we can add the subscribe method. So this would be equal to sub, respectively. This would be a minus b, and here I just want to create another method here, so let's call it sub. Okay, and the very last thing to consider would be to say just want to duplicate the code for subtraction. So int sub would be my class dot sub. So we're subtracting these two variables, and I want to print the sub, and this should be equal to 5. Now I just want to change this to sub as well. Oh, sorry. So hold on a sec. This is something that you might have encountered if you forget to assign, if you forget to initialize your function pointer. If you forget to associate your function pointer with the real function. So we need to say my class dot sub equals to sub, and now it should work. Okay, perfect. So 10 minus 5 would be equal to 5. So this is kind of it, and probably the very last thing to make it look like creating a real class instance. Well, obviously we're not going to be making a constructor to allocate the memory dynamically and all this stuff, but just this sort of a code would rather be encapsulated within the specific function. Let's call it init basically. So I just cut this from here, and here I want to initialize, well, let's say a constructor, but literally, obviously, it's not a constructor. Initializing constructor of our class structure, but again, like it's kind of like it's not the real. Okay, and here let's create a function called init, and I want to send the pointer to my class, and that's kind of it. So now we want to create this initialize kind of like constructor. So init, so this would be the void type, void init, and it takes my class pointer, let's call it in Python style, let's call this pointer self. Okay, and here we can simply say self, and now I'm using a different notation. So when we work with the pointer to the my class structure instance, we need to use this notation. While when we were working with the actual, not with the pointer, but with the actual instance, we were using this dot notation. So this a little syntax detail to consider. So here I say self and b would be equal to 5, and here respectively self add would be equal to add, and self sub would be equal to sub. Okay, self a like this. Okay, and yeah, also we'll say a and b here, and the here we'll say int a and int integer b. Okay, so initializing the constructor, and now we need to say the same like 10 or 5, and we should get exactly the same result, and we do. Okay, now just let's try some different numbers here. So let's say 20 and 10. Okay, so we got this 20, this 10, the sum is 30 respectively. The value after subtraction is equal to 10. Well, this is kind of it, guys. So for those of you who are purists, you might have make use of this sort of tricks during writing your own chess engine. So you might have treated this a and b variables like the board array or bitboards, no matter, like side to move and peasant square, castling rights, and then the functions would be like to print board, generate moves, and is skin in check, is square attacked, whatever functions you would like to consider, maybe like search the best move. So you can literally encapsulate everything within this single structure, then associate the function pointers with the real function pointers, and then make this fancy sort of a calls with this dot notation to say to access either the inner class fields or the class function pointers, which mimics the behavior of what happens when we call the method using the class instance in object-oriented languages. Well, this is it from my side, guys. I hope you've enjoyed the video and learned something interesting out of it. But before I end this video, I just want to say that actually using this sort of a function pointers when the structure definition is not, it seems to be a redundancy. So I just wanted to show you that this is possible, but on the real deal, nobody's actually using it. The way people do is way more simple, actually. So they just define the functions like this, and if they want to encapsulate board structure variables, they just declare a board structure here, and then then this init method shows literally whatever function that is working with the instance of this board class if we're talking about chess programming. So we just pass in the pointer to this structure instance, and then we can manipulate it. So let's say if we want to make a move or generate moves or just get some values or set them or whatever. So this is literally now just simply to send the pointer of the structure instance, like we've done here within our init. So let's say this is the print board position, so it would be like void print board takes board board pointer to the board, and then in order to loop over all the board squares, we just reference in this cell for board kind of like pointer to the structure instance, and then we can make use of the variables. So that's kind of it. Well, now this is really it. So I hope that this little piece of code will help you to understand how somewhat a more complicated chess engines work. I mean, somewhat more complicated than my BBC chess engine, which doesn't use this stuff but goes for kind of like global variables all along the way, as was mentioned in the beginning of this video. But I think after this explanation, things like we have, say, in Vice chess engine, just try to quickly reference the code, or also the same stuff we encounter in Fruit chess engine. So just okay, so I just want to get my chess programming repo here and go to didactic engines, and yeah, let's consider Vice and Fruit. So they both use the same kind of stuff here. So we have a look, let's say board.c. Well, let's say whatever function we take, so piece list OK, check board. So all of these functions take in the board position, the pointer to the instance of the board position, and as board is the structure here. So if we just have a look at the definitions, we just can see that how the board structure is. Just should be somewhere here. Yeah, this is the board structure. So whenever we want to reference this sort of a inner board fields or alter them or whatever, we just can we just pass the pointer of this sort of a board structure instance to whatever function, like we've seen here, and yeah, it doesn't redirect me back for some reason. Well, but I hope you understand what I mean here. So just using this pointer, and then we can say this position. So we reference here position piece number, what else? So here board position, referencing something else, position pawns, and so on, and so on. Position piece list, pieces, and all this stuff. So well, I hope this is quite pretty clear. But just a few notes. So when I was initially following this tutorial by Richard Albert, also known as Blue Fever Software, I didn't really. It was incredibly hard for me to get down with these pointers because I had no idea. I had no idea of what the pointers are actually and how to deal with them. I didn't understand all this low-level memory management stuff, and that was quite pretty complicated for me at that time. So that's the reason why I created in BBC Chess Engine tutorial series. I was using only global variables to make it easier for beginners to catch the very gist of chess programming without getting distracted by the C programming advanced techniques. And the same stuff used here in Fruit chess engine, which is much more sophisticated compared to Vice. But again, like you see, like this pointer to the instance of the board structure. So again, the same stuff here. So I hope this is quite pretty nice. So this is quite pretty clear of what's going on here. So we're referencing the board squares, board position, and also and all the stuff. So just like we were doing here, but much more complicated, obviously. But just still, the gist is kind of the same. Well, okay guys, so now that's really it from my side. Sorry for if I was talking too much. I hope to see you in the next tutorials on this chess programming channel. Until that time, and take care.